Okay, so here we have a hypothesis test example. It's a little dated. You might see the data we have is from 2006, 2007. So we'll throw back to what, senior year? So the College Board, they go ahead, they report that at private four-year colleges, the average annual cost for, I'm hoping, I don't know, maybe everything, but at least tuition, but for education is $22,218 per year. So nowadays, so the current year, they take a random sample of 50 private four-year colleges, and from this sample of 50, we get 24,000 per year on average. And we're going to assume the population standard deviation is 3,000. So we're going to perform a test to answer whether the cost of tuition at a private four-year university has increased. So we're not interested in just if it's different or if it's less. We specifically want to know if it's higher than in 2007. So also gives us a significance level, uses significance level 0.05. So we're going to go ahead, go through our steps. So question of interest is the mean cost of education for all, probably U.S. to be honest, U.S. private four-year colleges higher than, so the amount in 2007 was $22,218. We want to know, is it higher than that amount? What's great is if you set this up similar to the confidence interval, mean cost of tuition for all private four-year colleges. That's my parameter. It's nested right in the middle of that question. So hopefully these first two steps start feeling a little redundant. So parameter of interest. So I'm going to say X is education cost of private four-year university. So here's my notation, it's mu. And then, very important, and then my description and context, it's going to be the mean cost of education. And then it has to be for the population, so for all private four-year colleges today. So you might even want to throw in annual cost. You might even want to specify the US. So my inventory, so things to note, I'm looking at this claimed value. This value here does not come from the sample. It comes from a claim. The College Board reported that this was the cost. So this is my claim, so mu naught. So 22,218. So I take 50 colleges, so that's my sample size n. And then I have a mean cost per year for my sample of 50. So that's X bar. It's 24,000 per year. I don't know, I've never taken a sample of 50 anything and had a mean that was that friendly. And then we have a population standard deviation of 3,000. So that's sigma of X is $3,000. Just things to note. Mu, X bar, sigma of X bar, they're all going to have whatever units that the variable of interest is collected in. So here it's dollars. Oops. So state my significance level. It's really easy because they provide it. In general, if we don't have one provided, you can generally assume 0.05. However, if we include one, go with that. So my hypotheses, so mu naught, mu alternative, H naught, H alternative. See, mu x is equal to the claimed amount, so $22,218. So I included, you should always have your parameter of interest. In your null hypothesis, you should always have an equal sign, and then your claimed amount with units. So it's very important, we'll look for all of those things. So my alternative, it'll be the same parameter, it'll be the same claimed amount, but now the sign that we use, it's going to be based on the researcher's interest. So we want to know if it's increased, so we want to know if the mean has gotten higher. So basically, I'm interested in the scenario, hey, is the mean higher than the $22,218? If I don't get enough evidence, I'm not going to conclude that it's different than what it used to be. So checking my conditions here, I want to make sure I took a representative sample, so a random sample. So I took a random sample of 50 colleges. That should be good. The fact that I took 50, that means that I took enough. So n is 50. So even if it was a somewhat skewed population, this will be okay. So yes. And the population standard deviation is known. Yes, that sigma is equal to $3,000. So yes on all three. Calculate my statistic and p-value. So I'm going to even write here. So x bar is 24,000. Mu naught is at 22,218. N is 50. Sigma of x is 3,000. So I'm going to calculate a z statistic because I met all the conditions for z procedures. So that's going to be x bar, so what I observed minus what's claimed, over spread over the square root of the sample size. So 24,000, that's higher than what's claimed. I'm going to get a positive z statistic. 22,218 over, stripping out just a second, 3,000 over square root of 50. Do some math. I threw it into R. In R, it's a lot easier to do in one line than it is on a calculator for me. I end up getting something like 4.200, which is pretty big. So it's saying, hey, this getting a sample of 50, observing a sample mean of 24,000 per year, that's 4.2 standard deviations above the average. That's claimed. That's a lot. In general, if it's further out than 3, we tend to think that's pretty far. So things to consider if I want probability that, so we are looking at x bar because we took a sample, is greater than 24,000. So given that the null hypothesis is true, we want greater than because of the alternative hypothesis. It's the same as z is greater than 4.2. So this means that when I try to find that area that's going to be my p-value, I want the upper tail probability. So I'm going to pull out the probability z is greater than 4.20. Looking here, first off, I included the bottom of the table. You might notice I don't see a 4.2 anywhere in here. In fact, the highest this particular table gets is 3.49. So if it were 3.49, this area is 0.9998, and this area is 0.0002. 4.20 is even further over here, which means this area is going to be less than 0.0002. So my one-sided p-value is less than 0.0002. This is pretty small. Things to consider: it is a one-sided test. I only wanted to know if the tuition had increased, so I'm not going to multiply this p-value by 2. I can also use p-norm 4.2, and then I'm going to say lower tail is equal to capital F for false, and it will give you that probability. It's something like 0.0000133, which is less than 2 in 10,000. So either way, we'd be happy. If you told us the p-value is less than 0.0002, or if you told us it was equal to this, we'd be happy with either. So finally, our write-up. So I'm going to put 0.000013. So my p-value is very small. This is really strong evidence that the null is not true. So if the null was true, what I saw in my sample would only happen 0.0013% of the time. Extremely rarely. So I don't believe the null is true anymore. Oops. So we are going to reject the null because our p-value is very tiny. Our p-value specifically is smaller than our significance level. So at the 0.05 significance level. So you could say there is very strong, you could even say or convincing evidence to suggest that. And now we have to put the alternative hypothesis in words, in context. So that the mean cost of education for all private four-year universities, oops, I can spell, in the U.S. today has increased from, and you should put the null amount in here, so from $22,218. So we have very strong evidence that the average cost of private education in the U.S. has increased since 2007, which is not a surprise. I would be shocked if it decreased. I can't remember the last time I ever heard of tuitions being cut. Even OSU, I think we kept our tuition at the same place, but didn't actually reduce it. So that almost never happens. So this is our example. It's a hypothesis test looking at a cost of private education. Hope it was useful.